Hello, everybody. My name is Augustin, and I'm going to talk a little bit about Americano do Brasil Complex from Central Brazil today. So I'm going to give a brief resume about the geological setting of the intrusion to understand a little bit about it. So the intrusion is located in central Brazil, here. And in the central Brazil, we have the Tocantins province that it was a result of the collision of three cratons, the Amazonian, São Francisco, and Paranapanema cratons in the Neoproterozoic. And the province is divided between three belts, and I work on the Brasilia belt, that it was located between the Paranapanema and São Francisco cratons. And it's a very complicated geological setting, but on the western part of it, there's the Goiás Magmatic arc, where the intrusions that I work are located on. And between the Goiás Magmatic arc and a granulite terrain, there are several small to medium mafic or mafic intrusions. There's up to 16 identified so far, but could have more since there's a lot of soil package and it's hard to mapping. So far there's at least 16 intrusions. And I'm going to talk about Americano do Brasil. That is the most known because it was mined for nickel copper cobalt some years ago. So the Americano do Brasil complex is a small map of the intrusion. Is divided in two sequences, a northern sequence that is dominated by olivine cumulates and olivine pyroxene cumulates, and the southern sequence, it's composed mainly by pyroxene cumulates, ranging to pyroxene plagioclase cumulates. And they're divided by east-west fold, that we call Salgado Fold. So the northern sequence of the complex, as I said, there's olivine cumulates and pyroxene cumulates. So here it's just a section, and it's basically olivine cumulates that goes gradually to the appearance of pyroxene. And there's one ore body that we call S2. On this picture, it looks like it's on the olivine pyroxene, but actually it's only on the olivine cumulates. So the S2 ore body, as I said, is in the northern sequence, hosted by olivine cumulates, and it ranges from a disseminated neck texture to massive. It's a layer, actually. It goes up to 2 meters. It's not that big. So here it's an image of how it looks like. The mineralogy of sulfides is basically pyrrhotite, pentlandite, and some areas with more chalcopyrite here. As you can see, there's a lot of alterations, secondary alterations. The intrusion is metamorphosed to amphibolite facies, but has also heterometamorphisms to green schist in some portions. So everything it's very transformed, and it could reflect on the mineralogy. The southern sequence, it's kind of hard to understand more because it's very transformed. It's just in the south of the fold, and it seems the deformation concentrated on this part. So it's very transformed, it's very metamorphosed, but we still can identify igneous relics with pyroxene cumulates, minor olivine and pyroxene cumulates. And on the southern portion, we have two ore bodies, that is S2, that is located here, and sorry, S1 and G2 here. S2 is the biggest one, but it's formed from different small ore bodies. Yeah, there's a cluster of several irregular continuous ore bodies, but it goes to disseminated to massive lenses. The magmatic mineralogy is basically pyrrhotite and pentlandite, but as I said, we have a lot of alterations and very cross-cutting bodies, and a very huge hydrothermal alteration where we can change the mineralogy, and we have mainly pyrite on this one, on these alterations. And we also have the other ore body that it's hosted by olivine pyroxene cumulates. It's a very small one. It's an ore breccia and it's tectonized too. So to try to understand if the two sequences were related or not and how the placement of the intrusions happens, we try to modulate the formation of the cumulates. For that, we use the alpha melts, and you would try to identify a parental magma of these intrusions, because there was no constraint so far about how was the original magma. So after a lot of study, it seems that an iron-rich pickrite is the best option for these intrusions. And we use the country rock that are gneisses, granodioritic gneisses, to assimilate this granodiorite gneiss with the pickrite liquid. And we were able to reach all the rocks from the northern and southern sequence with the same pickrite liquid. What shows us that it's possible they are co-magmatic, represented from just different portions of the same magmatic system. And the difference of the northern and southern sequence was basically the amount of assimilation. So the northern sequence, there's basically non-assimilation, and the southern one would reach up to 45% of assimilation of the rose rock. So we also use the R factor model in the closed system R factor model to use this liquid to see if it was possible to form these intrusions. And the measured sulfide compositions falls basically between R values between 100 and 10,000, but it's not that much. And all the compositions I mainly bracket by the model curves of the sulfide segregation from melts, ranging from the parental pickrite melt that we use and the most evolved contaminated magma that it modeled. So they're basically explained by it, mainly the S2 ore body that is the most pristine one, that there's no much alteration. But we can still see that a very wide range of ore tenors between the various ore bodies. So overall, we could see that the S1 body, that is the one that I talk about, the pyrite, it appears to result from a different saturation later in the evolution of the magma, what agrees with our modeling, because it's more contaminated, and we could see in the field that it was more evolved. We have more plagioclase on these ones. And so it seems that this ore body, it's resulting in a later evolution. And the failure of a simple model, so I'll just back here. So we have some samples that are very out of the lines, mainly this S1 ore body. So it implies mainly the posting placement change on the system, because as I said, we could see that we have the alteration. We have an addition of sulfur on the system, and we have everything transforming to pyrite and chalcopyrite. So we could see that we go back to all the samples and we check it was mainly the metamorphosed ones or the less pristine ones. So yeah, and I think it was that for today.